Hello everyone, I am Venkat Reddy, Senior Project Associate and Postdoc Researcher at IISc Bangalore in 5G Testbed Lab. So what I am going to demonstrate here is a working 5G setup in a lab environment which comprises a commercial UE and open source radio access network and the core network from Niral networks. So what? So for radio unit, what we are using is IISc X310. And the radio access network, nothing but DU, CU, or using open air interface, open source code base running in this PC. So now I hand over to Mr. Prasenjit to talk more about the core network.
Yeah, hi, I'm Prasenjit from Niral Networks. So let me show you the core network. So as you know, the core network has two component, control plane and data plane. So the Niral OS core is running here. All the IMF, SMF, all the functionality. So it's all in the virtualized environment. And the data plane UPF is running here. Apart from the data plane, we have the media access controller also, which is running along with the UPF but in a separate virtualized environment. Okay, and here as we discussed, so Niral has these three components majorly. One is the core, the edge cloud and the controller. So here the controller is, if you have multi-site deployment, let's say in some power grid or port or this one, so Niral controller can be used from a centralized location to control all the network remotely.
So this is the commercially available phone that I am trying to connect this 5G network. So what you are seeing here is a G-Node B with IISc X310, which uses which is running in FR1 sub 6 GHz range and using 40 MHz bandwidth. And you can see the G-Node B is up and running, and you can see the log in the terminal. So right now this UE is in airplane mode. Let me just switch off this airplane mode and try to connect to the 5G network. Now you can see that this commercial phone is connected to the 5G network. And show you. And the APN is Niral OS IISc. So I will just browse the YouTube video and show you.
tubes to semiconductors, erasable programmable memory to index sequential access media, from how pixels were generated by a cathode ray tube to pins rearranging themselves to form ASCII characters by augmented printer. All this simply bewildered.
So this video is from the web. You can also see a video. It is available in the local core network, that is Mobile Edge MEC. Niral Edge. Niral Edge Gallery. Niral Edge Gallery. So this is locally available in the core network. You can see this Edge video running in commercial phone. So hand over to Mr. Prasenjit to to talk more about core network, the Niral OS core network.
Just now you have seen the two use case demo from Mr. Banker. So I'll explain the architecture, what is happening in the demo. So this is the complete end-to-end network. So this is your 5G UE having a 5G SIM which is connected to the IISc radio network, which is RU and DU. And then this is the Niral 5G core, which is the data plane controller and the server, mobile S server, and the UPF data plane is connecting to the public internet. So the first use case which you saw, the UE is connecting to the internet. So this is the path it is connecting. And the second use case where you saw, the mobile is connecting to the local MAC server, which is the hosted inside our private network. So this is a content server which can be used as a local server in the private enterprise environment. This can be even used for IoT analytics server and many other use cases. That's it for now from IISc 5G and Niral network collaboration. We'll come with more updates. Thank you for watching us.